Welcome to today's lesson on kinetics. If you remember the previous lesson, kinematics was ways to describe motion. With kinetics, we're looking at what are the causes of that motion. So what are the forces that are leading to that motion? And just like kinematics, we have a linear component and an angular component, so linear kinetics and angular kinetics. So in this lesson, we'll look at some of the different forces that impact motion and some of the other factors and considerations that have an impact on those forces. Let's examine linear kinetics first. So linear kinetics are the forces that help move that object in a straight line. So first thing we have is momentum, and momentum is mass times velocity. So therefore, something that has a large mass will have more momentum even if it's not moving as fast. I have a good example of this. When I first took my driver's test, I was driving an old huge car, and I came to the first stop sign. I stopped, looked both ways, and proceeded along, and the officer said to me, well, you didn't make a complete stop there because that car was so big, it still had momentum, so it took longer to stop. So therefore, I failed my driver's test the first time. Inertia is the principle that an object, if it's at rest, it's going to stay at rest, or if it's moving, it's going to stay moving, unless it's acted upon by an outside force. You can see the cat is at rest and laying on the dashboard. Mass and weight, sometimes people think these are equal, but mass is just the matter of the object. Weight is the effect of gravity. So mass has no effect from gravity. So if you look at the graphic, your mass on Earth versus your mass on the moon will be the same. But your weight is going to be more on the Earth than the moon because of the effects of gravity. The last concept we have is force, and force is the push-pull. So think about when you work out, you're either pushing or pulling different objects when you're working out. So those forces you're creating change the object, speed up, slow down, and change direction. Another aspect of linear kinetics are Newton's laws of motion. So he had three laws, and the first one deals with inertia. We already talked about inertia. So again, if an object's at rest, it tends to stay at rest. If it's moving, it tends to stay moving, okay, unless there's other forces that change that. Newton's second law of motion deals with momentum. So the force applied to an object is equal to the mass versus acceleration. So those forces, the mass and the speed, are all related. And the third law is action reaction. So if we have two objects coming together, that force coming together, there'll be an opposite and equal force going away. If you've ever seen two little kids run into each other, you've probably seen this concept applied. The last concepts of linear kinetics are kinetic energy and power. If we look at kinetic energy, again, an object has potential and kinetic energy. So potential energy is the stored energy in the object. Usually we're talking about gravity. And kinetic energy is when that object's in motion. So since the formula for kinetic energy equals half the mass times the velocity, we can see that the mass of the object plus the velocity, so how far it's moving in a certain period of time, is going to be the measure of that kinetic energy. We also have power, which is force times velocity. So the force that we're looking at, okay, is the work we're doing. So work is force times distance. So how much force were applied and how far the object's going to move. So power is how much work we do over time. So when we look at that force over time, that's how we come up with the formula: power equals force times velocity. So how how fast we can do our work. So if I'm lifting a weight, how fast can I lift that weight? That's demonstrating my power. We also have impulse, which is similar to impact. Again, this is the force times the time. So the impulse, that force, so again, how much force. So if I'm getting hit by an object, for example, if somebody's tackling me, there's going to be an impulse in that force. Angular kinetics are the forces that cause rotation. So if you look at the first graphic, somersaulting, if we're doing a somersault, we have to overcome the inertia of our body. So we have to create force to get that angular acceleration. Levers we already talked about. Again, to create that torque with the lever, we have to use, if we're doing our body, we're going to use our body in different ways. So the different levers of the body. Angular momentum, when a skater's doing a spin, if the arms are out, they're going to move more slowly than if the arms are in. And there's two reasons for that. One is the work that it takes to pull the arms in toward the body. That creates a force. Then also we're conserving the momentum, the angular momentum, when the arms are brought in, causing the body to spin faster. The last angular kinetics we have on there is force couple. Force couple is when you have two different forces, okay, moving in the same direction, okay, but not in the same line of magnitude. So if a wrestler is doing a takedown, okay, they're stepping in with the one leg, then bringing up the other leg to cause their opponent to rotate. So those two forces of each leg are causing the rotation of the opponent. In summary, kinetics are the forces that cause motion, and there's two main types. There's linear kinetics, which we're looking at the forces that cause an object to move in a straight line, and angular kinetics would cause an object to rotate. So when we look at different sports, you can look at your sport, your activity, and what are some forces that cause those different movements, and what are some forces that are needed for the different movements in your sport or activity.